Hi grade 10s, we're going to make our fourth video today on solving systems of equations. And again, today we're going to talk about how you can solve a system of equations by graphing. And we're going to look at page 4 and page 5 of the booklet. And to begin with, I want to look at this example from yesterday's video. It's two lines that were parallel, and so we realized that there was not a solution to the system of equations because those two lines would never touch. And the two equations looked like this. And when you look at these equations, it's not clear that they are parallel. So what I want to do is I want to show you how you can change the second equation and put it into slope y-intercept form, or mx plus b form, so you can see that it has the same slope as the first equation. So I'm going to do that now. I start with x minus 2y is equal to 4. And then I move the x to the other side. So then I have minus x. And then I need to divide everything by that negative 2. And when you do that, you see that the two equations have the exact same slope. And because they have the same slope, but different y-intercepts, they start at different spots, that's why those two lines are parallel but never touch. So let's look at page 5 now of the workbook together. Again, we are trying to find the solution to the system of equations. That means we're trying to find where the lines intersect. And the two equations that we're going to look at first are y is equal to 2x minus 3 and negative 6x plus 3y is equal to negative 9. The first equation is already in form mx plus b, so that's easy to graph. And the second equation is not, but we can easily use our intercept method to find the x-intercept and the y-intercept so that we can graph it. So first, I'm going to look at the equation where it's y is equal to mx plus b. The m is 2, so the slope is 2. It's jumping by 2, and it starts at negative 3, and this is what the table would look like. And now I'm going to do the equation that was not in the form mx plus b, and I'm going to use the intercept method to solve this question. We know that when we have a y-intercept, the x is always equal to 0. So to find the y-intercept for this one, we're going to cross off the x and make this equal to 0. So I have negative 6 times 0 is just 0, so I don't need to write it down. 3y is equal to negative 9. Y is equal to negative 9 divided by 3. Y is equal to negative 3. So my y-intercept, if I were to graph it, my y-intercept is negative 3. Now I want to find my x-intercept. So it's just the opposite. Negative 6x plus 3y is equal to negative 9. If I want to find the x-intercept, then I'm going to make y equal to 0. And I'm going to isolate for x. So that means that x is equal to 9 over 6. Those two negatives would cancel each other out. Okay, and 9 over 6 is just 1.5. So my x-intercept up here, 1, 2, my x-intercept is right here at 1.5, and I would make a line through that to graph it. Now, let's graph both on the same grid, and let's see what happens. So the first thing I did was I graphed y is equal to 2x minus 3. It starts at minus 3, and then I followed the table of values and plotted all the points. Now what I want to do is I want to graph the second equation where I know the y-intercept is minus 3 and the x-intercept is 1/2. And let's see what happens. Something interesting is going to happen. Okay, so my y-intercept is minus 3. Oh, that's the same as this one. So I'm going to put... And then my x-intercept is 1/2. 1.5 is right here. It appears like it's the exact same line. It appears that this equation and this equation give you the same line. They're just written differently. So let's see what happens when I draw the black line on the graph with the green line. So I've graphed the black line, and what you can see is the black line just covers the green line. And that makes total sense because they have the same y-intercept, they have the same x-intercept, they're actually the same line. So in this case, if I were to answer the question, what is the solution to the system of equations, you would say they're touching all the time. There's not just one intersection point, they always intersect, or they always touch. So that means there are like a million, a gazillion places where those two lines touch. So you can't just say there's one intersection point, you would say they always intersect. So during our first 4 videos, we've seen the 3 things that can happen. If you have 2 lines, they can intersect and touch at one point. So that means there's one solution to the system of equations. Or, like yesterday, the 2 lines could be parallel, and that would mean that there is no solution because the 2 lines don't touch. Or, like today, you could have 2 lines that are actually just one line and they're on top of each other. And if the 2 lines are on top of each other, they're always touching. So there is an infinite, that means a number so big you can't even count it, an infinite number of solutions. What I want you to do today is just one question. Yesterday I left you with 3 questions, so today is easier. I want you to try this last question in the red box on the bottom of page 5. Try it. See if it's one solution, no solutions, or a million gazillion solutions, and let me know. Send me an email. Add a comment to the bottom of this YouTube video so I know you've seen it. That really helps me to know who's watching, who isn't, if the video is helpful or if it's not helpful. Okay, thanks a lot. Bye.